record. Example 3 here, okay? The fourth root of -2 times the fourth root of 8. What do you get when you simplify that? Fourth root of -16, okay? Try that in your calculator. So this will be 4 math 5 and then -16. No solution, okay? There is no real solution when you take the fourth root of a negative, okay? So if this number is even, if your index is even and there's a negative radicand, a negative under your symbol, no real solution, okay? Look at number 4. Cube root of 7 times the square root of 21. What do you see? One's a cube root, one's a square root, okay? You cannot do that. If these are different, we have to say there is no solution. You cannot multiply a cube root times a square root. So your index has to be the same, okay? Pay attention to the index. It's a small number. It's so teeny and so easy to miss. So make sure you're looking for that, okay? Okay, moving on. Number 5 here. So this one, let's say we had this problem. We already multiplied it together, and now we have this radical, but we want to simplify it. What we do is we're going to break it into, and I always set it up this way, the perfect squares or perfect cubes, perfect whatever. So in this case, it's a perfect square we're looking for because our index would be 2, right? And then this one is the one that is not perfect, whether it's a cube or a square or whatever we're working with. So we're going to break it into 2 different things here. So first, just look at the number. The number 75, okay? If you go back up to the top, we made this list of all the perfect squares, right? This is why I say put this at the top of your homework, because these are the numbers you're going to look to. If I have the number 75, I'm asking myself the question, what could I divide 75 by in this list of numbers? Do you see one? 25, okay? So we're going to break it into 25, and it's 25 times what? 3. So the 3 is going to go over here because that's not a perfect square. But then we also have our exponents, okay? Now, remember what we said before. You always take the exponent divided by your index number, but 3 divided by 2 is not nice. We don't like that, okay? So instead, we're going to break it into what can be divided by 2 and what can't be divided by 2. So if I have x to the 3rd power, I'm going to put x squared here because 2 can be divided by 2. So that's a perfect square. What are you left with then on the other side? X, okay? Now this simplifies much nicer than it would have before. So this becomes 5. What's the square root of x squared? X. And then we still have the square root of 3x that we can't do anything with. So that's your final answer. Okay. Questions on that? We're going to do a whole bunch of those. So if you didn't get it that time, stick with me. We're going to do it again. Okay, number 6 here. Notice this. This 2 is not this 2. Okay, that's not the index. It's a 2 out in front of my radical. So we're saying 2 times the square root of 32, x to the 4th, y to the 9th. So don't forget about that too. Remember, that's one of those guys that just gets forgotten about all the time, like we did in first semester. We're going to break the 32 x to the 4th, y to the 9th into 2 separate things, the perfect squares and the non-perfect squares. Do you know of a perfect square that 32 is divisible by? 16. So we're going to go 16 times 2. Okay. Now look at your x's. Can you take the square root of x to the 4th? Yes. Even numbers, guys. The trick is even. If it's a square root, we want a number that's divisible by 2. So we want even numbers to go in our perfect squares. So x to the 4th is going to go there, which means we have no x's on the other side. Now look at your y's. Can you take the square root of y to the 9th? You can't, right? We want an even number. What's the next even number below that? 8. So we're going to put y to the 8th here, which means we have how many y's left on the other side? 1. Y to the 1st. Okay? Now we can simplify. This becomes 4x to what power? The second, right? 4 divided by your index, which is 2. 4 to the second. Y to the 4th. Okay? Don't forget about your friend, the 2 out in front. So last thing to simplify is just to multiply those two. 8x squared y to the 4th times the square root of 2y. Make sense? You've done this before, just maybe not on this scale, right? Not this many numbers and variables and things, but you have done this before in algebra and even a little bit in geometry last year. Okay, number 7 has a kind of a new element. Now it's a cube root, so we got to think of our perfect cubes. Remember up here, now we're going to be looking at these numbers to try to simplify this. And it changes how we work with our exponents to our variables, okay? So first of all, this is going to be a cube root of something times a cube root of something. Can you find a perfect cube that 80 is divisible by? What is it? 8, yeah. So 8 times 10 gets us 80. Okay, now how does this change with our exponents, do you suppose? X to what power is going to go on the perfect side? X to the 3rd. Think of it this way. It has to be divisible by 3 now, right? So we're going to go x to the 3rd, which leaves us with how many x's over here? 2. Okay. Now look at your y's. Y to the 6th. How many of those can go? All of them. Yeah, 6 is divisible by 3, right? So it's going to be y to the 6th here. And then how many z's? Z to the 6th, which means we have 1 z left. Okay. So pay attention to your index. That 3 is what tells you our number has to be divisible by that number, by my index. Okay, so now simplify that. What is the cube root of 8? 2. What's the cube root of x to the 3rd? X to the 1st, right? 3 divided by 3. What's the cube root of y to the 6th? Y squared and z squared. Okay, so it's just your number divided by your index. And then what you're left with, don't forget to put the little 3 in there, the cube root of 10x squared z, and that will be your answer. It's kind of fun, right? I love this stuff.
For the x, didn't you say you always have to go down to the next even number? So why
That's if it's the square root. We do even numbers because you're dividing by 2, right? Now this one, it's a cube root, so we have to be able to divide it by 3.
Okay.
So always think divide by the index, whatever that index number is. Yeah. Okay, now we're going to combine what we did in the first couple of problems with what we did in the second batch of problems in this third batch of problems. So number 8, what do you suppose we do first? We're going to combine it all into one big radical, okay? So it's a square root, and we're going to go 8 times 6 is 48. What's x to the 3rd times x? X to the 4th. And then y squared times y to the 3rd is y to the 5th. Okay, so we combine it, and now we're going to break it down again, but we're going to get some nice perfect squares out of this. So when we do that, can anyone find a perfect square that 48 is divisible by? Do you know how to do this? Like if you don't know what the perfect square is, you can just take your calculator. I wish I could jump back and forth much quicker than I do. Let me just show you. 4 works. 4 is not the best one.
16.
Yeah, you want to start high. Let me show you. So if I'm working with a number like 48, I'm going to go 48 divided by, and then look at your list of perfect squares. So say you thought maybe 36 will work. It won't, but you go 48 divided by 36. If you don't get a whole number there, it doesn't work, okay? So when you do 48 divided by 16, you get a whole number. So 16 and 3 are your two numbers, okay? If you don't know how to find those, that's the process you want to use. A lot of these are going to just become like second nature to you by the time we're done, because I see them so much. So, okay, so this is 16 and 3. X to what power goes under the perfect side? To the fourth. Remember, our index is a 2, so we need to be able to divide it by 2. Y to the fourth also, which means we're left with one more y on the right side since we started as y to the fifth. And now you can take the square root. So square root of 16, that's 4. Square root of x to the fourth is x squared. Square root of y to the fourth is y squared. And then we have the square root of 3y. And that whole thing is your answer. Okay. Number 9. Number 9 gets a little bit fancier because now we have numbers out in front. Okay. So those numbers you can multiply. So just multiply that right off the bat. 3 times 2 is 6. And then this is a square root. So you're going to go 21 times 7, which is 147. R to what power? The third and the third would be r to the sixth, and then s squared. Okay, and now we're going to break it down. Don't forget about your 6 out in front. So 6 times a perfect square and a non-perfect square. So here you go. 147 divided by 81. 147 divided by 64. 147, keep working your way down until you find the one that it is. Anyone know which one it is? It's 49. Yeah. 147 divided by 49 is 3. R to the what on the perfect square side? All 6 of them, right? Got to divide by 2 because our index here would be 2. So then it's s squared also because that's divisible by 2. So then simplify that. 6 times 7, r to the third, s to the first, and the square root of 3. 6 times 7, mental math, 42, r to the third, s rad 3. It's so satisfying, right? Like, turn it into this huge thing that simplifies down to something so much nicer. I love it. Any questions on those so far? Okay, number 10. Notice this is cube roots. Okay, so we need things that are divisible by 3 with our exponents. But the first thing we're going to do is multiply it all together. So it's going to be a cube root. So 54 times 5 gets us 270. X squared times x to the third would be x to the fifth. Y to the third, y to the fourth would be y to the seventh. Do you see the perfect square? Sorry, the perfect cube. That goes into 270.
30?
3 would work, but you're going to have to break it down again. You want to start with the high end, right? So 27 works quite lovely here. So it's going to be cube root of 27 and the cube root of 10. X to the what?
Third.
The third on the perfect side, which means you have x squared on the not perfect side. And then y to the sixth, which leaves us with 1y on the other side to add up to 7. Okay. Cube root of 27 is 3, right? 3 times 3 times 3. Cube root of x to the third is x. Cube root of y to the sixth. So you take 6 divided by 3, you get y squared. And then we have this left over. Cube root of 10x squared times y. All right. Okay, I want you to try number 11 on your own. It looks frightening, right? It doesn't look friendly. It's actually much more friendly than you think. What do you do with that rad 3? Distribute. Start there. Distribute that. See what you can do with it. I'm real curious who will catch it. What'd you ask, Ariane? What did you ask? What to do? Distribute. This times this. That times that. What's the square root of 3 times the square root of 3? Square root of 9. What's the square root of 9? 3, right? So you're just going to break it into two things, but we're adding in between them. We'll walk through it in just a minute. Anyone have an answer? What'd you get, Noah? Yes, good job. Anyone else get 3 plus 3 rad 5? Did anyone get 6 rad 5? It's a very common error that I'm going to try to steer you away from right now. So rad 3 times rad 3 is rad 9, right? Plus rad 3 times rad 15 is rad 45. So you have rad 9 plus rad 45. Well, rad 9 is 3. And then rad 45, we can break down the square root of 9 times the square root of 5. The square root of 9 is 3, so we have 3 plus 3 rad 5. And a lot of people right there are tempted to add the 3's together. Why can't we? Right, the 1 is being multiplied by the radical, and you have to multiply before you add, and we can't multiply 3 times rad 5 to simplify it. So you cannot keep going there. Those are not, we kind of treat it like terms, right? They're not like terms. If one has a radical and one does not, we can't do it. So 3 plus 3 rad 5 is as far as you go with that. Questions? Okay, then my question. Do you need a brain break? You need like 2 minutes to move around and stretch and, okay. So we're gonna do division now, okay? And division is very similar in terms of like how it becomes what we can work with. If it was separated like this, you're allowed to divide the two numbers as long as they have the same index again. Okay, so a cube root divided by a cube root, you can take the radicands and you can divide them. Okay? The one restriction here is b can't equal 0. Y can't b equal 0? Can't divide by 0. Okay? So that's the only restriction that we have. All right, so dividing. The square root of 50 divided by the square root of 2, what would that be?
25.
The square root of 25, which is 5. Isn't that lovely? Like, it looks horrible. It's quite lovely. It's lovely. All right, number 13. Now, these are cube roots, but they're both cube roots, so you're allowed to divide them. What is 32 divided by 4? 8. So you get the cube root of 8. And what is the cube root of 8? It's 2. Okay. Oh, if they were all just this easy, huh? Okay, cube root of 81 divided by cube root of negative 3. So you're going to go 81 divided by negative 3 is going to get you a negative 27. So the cube root of negative 27, again, you're allowed to plug that into your calculator. It's math 4, negative 27. What do you get? Negative 3. Negative 3 times negative 3 times negative 3 is a negative 27. Yeah, when you hit math, hi, how are you? Good. Matthew, this is for you. Okay, so when you hit math 4, it drops that symbol in for you. So just hit math 4 and you'll get the cube root. Okay, 15. This one's a little bit different because we got some variables with exponents. What do you get when you do this? If we divide it, the square root of 16 X squared, right? When you're dividing variables with exponents, you're subtracting. This is x to the first, so that whole thing is x squared. What is the square root of 16x squared? 4x, yep. Good? Yeah, Jada. So the square root of x squared, you take the 2 divided by 2 is x to the first power, right? So think about what your index is. Divide this by the index. Okay, we're going to get a little fancier now. Divide and simplify. So really, the only new thing here is that we're dividing. Once we divide, it's going to look an awful lot like what we just did on the first page. So square root of 24, m to the 4th, divided by the square root of 2m. So the first thing you want to do is divide it. What do you get when you divide this? 12m to the 3rd, okay? Now, some of you might be thinking, can I just take that and call it m squared outside of the radical? And you could, but it makes a whole lot more work for you because you can't leave a radical in the denominator, and that doesn't get the radical out of the denominator. So if I were you, I wouldn't, but you can. It's possible. Break this down. Perfect squares, non-perfect squares. What's the perfect square? 4. 3 is the non. M to what power? Squared, which leaves us with 1m over here. So the square root of 4m squared is 2m. And then we have rad 3m. And that, my friends, is your answer. Questions on that? All right, let's check this one out. So this one's cube roots. We're going to start by dividing. So it's going to be the cube root of 162 divided by 3. You can just plug that into your calculator if you can't do that in your head. That would be 54. P to what power? P to the 3rd. 5 minus 2, right? When you're dividing, you're subtracting. So P to the 3rd power. And then what? Q squared, right? There's no other Q to do anything with that. Okay, so we're dealing with a cube root. We got to break it down into perfect cubes. Don't forget your little 3 out in front, your index, and the non-perfect cubes. Do you know what perfect cube 54 is divisible by? 27. Remember, just go back up to that list up top. 54 divided by, 81 doesn't make sense, right? 54 divided by 64 doesn't make sense. 54 divided by 27 is lovely. 27 and 2. P to what power is going to go on the perfect side? The 3rd, right? We want to be able to divide these, and we can. So P to the 3rd. Where does your Q squared go? The right side. Can't take the cube root of Q squared, right? 2 divided by 3, we don't want a fraction, so can't do it. The cube root of 27 is 3. The cube root of P to the 3rd, P. And then we have the cube root of 2Q squared, and we're done. Gosh, I love this stuff, you guys. This is so fun for me. Okay.
Go back to
16, yes. Did you have a question about it, or you just needed to make sure you had it the right way? Okay. All right, number, what? Yeah, that's the really fun stuff. Number 18. Okay, now these are 4th roots, but you do the same process. So take those numbers and divide them. 1,024 divided by 4, you can plug that into your calculator. 256. So this is the 4th root of 256. X to what power? 14th. Yeah, we're going to subtract those. 15 minus, this is essentially a 1. Okay. Now here's the deal. God bless you. That's a 4th root. Okay. So you can try plugging that into your calculator right now and seeing if it's a perfect root. Or then you just start working your way down dividing. Now, typically, we didn't even give you a list of perfect fourth roots, right? It doesn't happen a lot that it's going to be broken down into other things. A lot of the times, it is just a perfect root already. So plug it in. 4, math, 5, 256. What do you get?
4.
4, okay? So that is a perfect fourth root already. So we're going to put the 256 on the perfect side. X to what power do we do here? Think through how we've been doing it. It's the exponent divided by the index needs to be a whole number. 12, yeah. So we're going to put a 12 here, which means we're left with x squared over here. And then you can actually take that fourth root. So the fourth root of 256, you already told me was 4. X to what power then? The third power. 12 divided by 4, right? So x to the third power. And then it's the fourth root of x squared that we can't do anything with. And you're done. And again, just don't forget to write that 4 in there. A square root and a fourth root are very different, right? If you don't put the 4 in there and then you see the square root of x squared, you'd actually probably take the square root of x squared and call it x, and it's not x. So just be aware. Okay. Last thing, rationalizing. This is everyone's favorite part. Rationalizing just takes a little bit of steps involved here. You cannot have a radical in the denominator, right? It's not allowed. Your final answer has to be rid of all radicals in the denominator. So we rationalize. Does anyone remember how to rationalize this? What do you do?
Multiply both sides by the denominator.
Yes, multiply both parts by the denominator. So we're going to multiply by the square root of 3 over the square root of 3. Why do we do that? Why am I allowed to multiply by rad 3 over rad 3? Because it equals 1, right? We're not changing the value of it. We're just rearranging where things are. That's the only reason we're allowed to do that. You can't just pick a random number and say, oh, I'm going to multiply by the square root of 7. You can't. You have to multiply by 1 so we don't change its value. But in doing this, then, we're just going to multiply across. So rad 2 times rad 3 is rad 6. Rad 3 times rad 3 is what?
1.
It's rad 9, which is 3, right? So you're left with this. Can you divide that? Rad 6 divided by 3. One's a radical, one is not. Don't divide, okay? If they're both radicals, then yes, divide them. But if one is and one isn't, then you can't, and you are done. Okay? Okay. This one, example 20 here. Again, whatever you can divide, if you want to divide right off the bat, that's great. There's not a lot you can divide here, but it is helpful to do the division here just because it's going to simplify life in the long run. So if you look here, you have x's. What's the square root of x to the third divided by the square root of x? The square root of x squared, right? So that goes on top, the square root of x squared. On bottom, you are left with the square root of 5y. Okay? I would then call the square root of x squared what?
X.
Just x. Yep, call that x. So this is going to be x divided by the square root of 5y. What are we going to do to rationalize? Multiply by what? Square root of 5y on top and bottom. All right, we're just multiplying by 1, but it's going to help us rearrange some things. So multiply across on top. You get x times the square root of 5y. Okay, what happens when you multiply a radical by itself? The square root of 5y times the square root of 5y is 5y, okay? It always becomes your radicand because basically we're saying this is the square root of 25y squared, and when we square root that, it goes back to this, okay? So I don't need to see this step from you. If you want to show me that step, great. But when you see a radical times itself, just write it without the radical symbol. It will always be that. So this is your answer. Again, you cannot divide a radical and a non-radical, so don't divide those 5 y's. Not possible. Okay? Okay, I'm going to have you try number 21. See if you can figure that one out from what we were doing. What was your first step here? Take that x to the 5th and the x squared, right? And what do you get when you divide that? X cubed. Okay, so you have the square root of x cubed up top. On bottom, now your x is gone because we just subtracted that. So this is going to be the square root of 3y. Okay. Now, again, you kind of have options here when you do what. I like to get the perfect square out right away. So I would call this the square root of x squared times the square root of x, right? I would break that into the perfect square and the non-perfect square just to simplify it a little bit. So this would be x, the square root of x squared, times the square root of x. And then on bottom, we still have that square root of 3y. What do you do next? Multiply by that denominator over itself, right? So the square root of 3y over the square root of 3y. Okay, that means up top, I have x times the square root of what? 3xy, right? You just multiply all the pieces, put it in alphabetical order is typically what they say. So the square root of 3xy over 3y. Ditch the radical, right? Because we're taking a radical times itself, so it's just going to be 3y, and that is your answer. Any questions on that? Okay, we're almost there, guys. We're so close. These last two are probably the two that have the potential to be mistaken because they're cube roots now instead, and people tend to just forget them and forget the process for a cube root. Think about it this way. You have cube roots. In order for me to get that cube root out of the denominator, I want my denominator, instead of to be a perfect square, which is what we did before, now I want it to be a perfect cube, okay? So you are not just gonna multiply by the denominator itself, okay? Instead, we're gonna multiply by something that will turn it into a perfect cube, okay? Maybe you wanna make a little note of that by here. Make the denominator a perfect cube, okay? So let's think about that. Right now on bottom, you have 3x. Is 3 a perfect cube? No, right? Is x a perfect cube? Can you take the cube root of x? No. Okay. So I want to turn that 3 into something that I can cube root. What's the first number in our perfect cubes that would be divisible, or not divisible, that would be able to be taken a cube root of? Okay, so 8, 3 times something will get us 8. Is there a number that works with that? No. Okay, what's the next cube root? 27. 3 times something get us 27?
Yes.
Yeah. So what we're going to multiply by here is the cube root of 9. And then x to what power, when we multiply those two things together, when we multiply these two things, will get us something that's cube rootable. The second power, yeah, because it'll get us x to the 3rd, right? So we're trying to make that bottom a cube root. Okay, so that's going to do it. So write that up here as well, because we got to multiply by 1. Okay, multiply across. We get the cube root of 2 times 9 is 18, x squared on top. On bottom, it's the cube root of 27 x to the third. Now let's simplify that. What is the cube root of 27? That's 3. What's the cube root of x cubed? X. So on bottom, we have 3x, which is what we want. We don't want a radical down there. So we're in good shape there. Up top, you have to ask yourself, can I take a perfect cube from 18? What's the first perfect cube? 8. Is 18 divisible by 8? What's the next perfect cube? 27. Is 18 divisible by 27? No. So you can't do anything with that 18. Can you take the cube root of x squared? No. So that's just going to stay x squared, which means this is your answer. Okay, got to get the radical out of the denominator. Once you do, if it's as simple as you can go, then you're good to go. Okay, do you want to try one on your own? It's the last problem. You want to give it a go? See if you can come up with it? I'm not going to give you the option. Try it on your own because I want to see if you can get there. So remember, we're trying to multiply by something that will turn our denominator, once we multiply, into a perfect cube root, okay? So see if you can come up with what you would have to multiply top and bottom by to make this together a perfect cube. Who's going to be bold and give me an answer? Did you get something? It's okay to be wrong. You learn from mistakes. You really do. Jonah.
Cube root 10 y to the second over y squared over 2y.
Good job. Anybody else get that? That's the right answer. Okay, so to make your denominator a perfect cube, 4 times 2 will give you 8, and 8 is a perfect cube, okay? So that's good. And then y times the y squared will get you y cubed, also a perfect cube. So when you multiply across, you get 8, right? 4 times 2, y squared times y is y cubed. So we're going to multiply by the cube root of 2y over the cube root of 2y. When you multiply across on top, you get the cube root of 5 times 2 is 10. Y times y is y squared. So when we do that, nothing you can do on top. There's no perfect cube that 10 is divisible by. There's no perfect cube that y squared would be divisible by. So that on top, the cube root of 8 is 2. The cube root of y cubed is y. And that will be your answer. Good to go?